Hey everybody. In class the last couple days we've been talking about linear equations or linear functions. Remember, a linear equation is anything that can be written as y equals mx plus b if m and b are replaced by numbers. Right? So something like y equals 1/3 x minus 2 would be a linear equation. We have 1/3 for m, and we have -2 for b. Now, we also saw that we sometimes have equations that are not written in this form, y equals mx plus b, right? We might have something like 4x minus 6y equals, let's say, -18, right? And we can put this in that form. We can rewrite this as y equals mx plus b by solving for y, right? I can subtract 4x to start, minus 4x, minus 4x. We'll get 0 over here. We'll have -6y left. We'll have -18 minus 4x. We can't combine those two. And then we can divide by -6. Divide by -6. Here we get y equals, now we can think about this as -18 over -6. And we can think about this as 4x over -6. Now -18 divided by -6 will give us 3. And because of this minus sign, we can think about this as -4. -4 over -6, we can simplify that if we have -4 over -6, that equals 2 over 3. So we can rewrite this as plus 2 over 3x, right? And now this is in that form that we talked about up here, y equals mx plus b. We have 2/3 as m, and we have 3 as b. So this is a nice form of the equation because it looks more like a function, right? We have the output over here, and that's equal to an expression that involves the input. So we can put the input in, we calculate, and we get the output. Now, there's a name for this form of the function as well, though. We call this standard form. So 4x minus 6y equals -18. We say that as in standard form. And standard form is any time we have x and y on the same side of the equal sign. Okay? So any number times x plus any number times y equals c. Now the only requirement here is that b does not equal 0. Remember over here when we divided by the number in front of y, we can divide by -6, we can divide by any number except for 0. So this number cannot be 0 here because eventually we'll have to divide by that. So this is what standard form looks like. We're not going to spend any more time tonight talking about standard form or linear equations in the y equals mx plus b form. We are just going to talk about equations tonight that only have one variable and what those lines look like. So in these next two examples, we're going to graph two equations, and both of these equations only have a y equals 2, y equals -5. How do we graph this? What do we put in for the input if we don't have an x? Now, this equation, we know that the y-coordinate of every point is going to be 2, right? Y has to be 2, y equals 2, that never changes. So, for instance, 0, 2, the coordinates here, 0, 2, make this equation true, right? We can substitute the y variable, put 2 equals 2. Now there's no place to put the 0, so that really doesn't even factor into it. So 2 goes into y, 2 equals 2. This point is a solution to this equation. We can plot another point. Let's say we plot it at 3, 2, right? If I have a point 3, 2, now in this case, once again, our y-coordinate is 2. We put in 2. There's nowhere to put this 3. So once again, we just have 2 equals 2. This point is also a solution. There are lots of solutions. Negative 1.5, comma 2 is a solution. Negative 47, comma 2 is a solution. And in all those cases, all these cases on our coordinate plane, any point that has a y-coordinate of 2 is a solution. So we can draw our line just like that. Every single point that has a y-coordinate of 2 is a solution. For example, B here is going to be very similar, right? 0, negative 5 is a solution here. Put in negative 5 for y, we get negative 5 equals negative 5. This equation is true, so we can plot that point. 2, negative 5 is also a solution. 2, negative 5 on the coordinate plane is a solution. Negative 3, negative 5 is going to be a solution. 5, negative 5 is going to be a solution. You get the idea. All of these values that have a y-coordinate of negative 5 are solutions, and therefore our graph is going to consist of those points. Now, when we look at these lines, notice the shape of these lines. Notice the direction they're going. These are perfectly horizontal. Okay? Anytime we have an equation that looks like y equals a number, we will get horizontal lines. Here, we have the opposite version of those equations. Instead of having y equals just a number, we have x equals just a number. No y to be found in this equation. Now, if we're thinking about what points are going to satisfy this equation, are going to be solutions, we know our x value has to be 4. There's no y to be found. So x has to equal 4 for all of our solutions, which are all of the points that will be on the graph. It doesn't really matter what the y's are, just like we saw in the last two problems. It didn't matter what the x values were, right? 4, 0 makes this equation true because 4 equals 4. The 0 never even comes into play. We could also do 4, 3. That makes the equation true because the 3 never actually gets substituted. We could do 4, negative 2. We could pick all kinds of different points as long as the x value is 4. Now if we plotted all of these points, 4, 0 would be right here. 4, 3 would go right 4 and up 3. 4, negative 2 would go right 4 and down negative 2. So this time we would have a straight line, and our straight line would look like this. All of the points that have 4 as an x-coordinate. D is going to be pretty similar. X has to be negative 1 for this equation to be true. So we can come up with a bunch of different points where the x-coordinate is negative 1, right? Negative 1, 0 would work. Negative 1, 5 would work. Negative 1, negative 1 would work. Because all that matters is that we have a negative 1 to substitute into x. Negative 1 equals negative 1. So on this graph, these points are going to look like this. Left 1, and then on the x-axis, left 1 and up 5, that's negative 1, 5. And negative 1, negative 1, left 1, down 1. We're once again going to have a line, make that point a little more on our line there, that is completely vertical. Anytime we see an equation where x equals just a number, there's no y, just a single variable that's x, we're going to have a vertical line. So that's our big takeaway for today, how to graph horizontal and vertical lines. Anytime you see a horizontal line, you know the equation is going to have y equals just a number, no x variable when we have a horizontal line. Same thing with vertical lines, we have x equals a number, no y variable. That's it for today. Go ahead, finish up your notes, submit through Canvas, and I will see you all tomorrow.